for this problem, so Zion jumps straight up, reaching a maximum height of 45 inches. So one important thing to know is that at the very top of this vertical leap, he would be momentarily at rest when he gets to the very top. So if I only look for, or if I only analyze Zion's way up, then V2 would be 0 meters per second. So on his way up, V1 is some sort of launching speed that we're going to solve for actually in part B. But gravity is going to slow him down, and eventually he'll come to a stop for a moment, and that'll be at the very top of his jump. So I did mention gravity, so this is a free fall type question. So the acceleration is going to be 9.8 meters per second squared. It's going to be down. I think I will go with negative 9.8 meters per second squared up. And the other piece of information that we're given is the 45 inches. So the 45 inches, that would be his displacement on his way up. So it would be 45 inches up. In this case, we've got meters and inches, so that's not consistent. So we're going to make some kind of conversion to get everything into the consistent units. So I think it's easiest to go with meters. So I'm going to convert the 45 inches to meters. I'm going to get Google to do that for me. And it is giving me 1.143 meters. I'm going to underline 2 sig figs there because the original 45 inches had 2 sig figs. Okay. What I need to solve for is time. It says how much time would he be airborne for this leap. So this delta t I'm going to calculate is for the way up. In this case, it's going to be symmetrical on the way down. So whatever amount of time he spends going up, he's going to spend the same amount of time falling back down to the ground. So I'll just multiply my answer by 2 once I'm done. So I've got to look for the kinematical equation that's got these 4 variables in it. And the one that I see from my formula sheet, if you have that in front of you, looks like this. And the V2 is 0. So 0 times anything is 0. So I'm going to wipe out this first term here. That kind of goes away. I'll just rewrite the whole thing without that term. Make it a little cleaner. So this is the equation which I want to solve for time with. So let me just go over here. So I got to isolate that for time. So here are the steps. I'm going to multiply both sides by negative 2, first of all. That's kind of the inverse of the negative 1/2 there. But then I'm also going to divide both sides by acceleration. And then I'm going to square root both sides. Doing all those steps, I'll end up isolating for time. All right. There's a plus or minus. Like when you do the square root of both sides, you should write plus or minus because there's usually the two options, but we're solving for a time here, and a negative time doesn't make sense. So the negative is going to be inadmissible. Okay, I can go ahead and fill in my values. So the displacement is 1.143 to 2 sig figs, and the acceleration is negative 9.8. Yeah, at the beginning of this question, I had to decide between listing acceleration as 9.8 meters per second squared down or negative 9.8 meters per second squared up, which I ended up deciding to do because I needed the direction to match with my other variables. So my displacement is up, so that's why I chose to write acceleration in terms of the up direction. Okay, so let me try to put this whole thing in the calculator here. I'm typing it in, but I notice, and it's a good sign, that I have a negative in the numerator as well as a negative in the denominator. So that'll end me up with a positive in the radical, which is what I want. I don't want the square root of a negative number. Okay, so I think I have it here if I typed it in correctly. 0.154 seconds. So once again, this is just on his way up. That's going to be to 2 sig figs. But the total airborne time, which is what the question asked for, is going to be double this because he's going to spend the same amount of time coming back down. So that's why it's important for me to keep that one extra digit, that 4 there, because now when I double this, it's going to end up being 0.308, which that 8 will make me round it up to 0.31. If I did not keep that extra digit of a 4 there, if I just left it as 0.15 and doubled that, I get an answer of 0.30, which would be a little bit less accurate, a little less accurate than it should be. All right, so that's part A. Part B, what speed would he launch himself from the ground with this leap? So same thing. I can keep the same, I'll just analyze the way up here. I can keep my same givens. But now I'm just solving for a different unknown. The unknown I'm solving for would be the launching speed, or v1, the initial speed or velocity. Speed and velocity are going to be pretty much the same thing in this case, since we're in one dimension. The magnitude of the velocity is going to be the same as the person's speed. All right, so I just take a look at my list there and the 4 variables I'm working with, and see if there's an equation that's got all 4 of them in it. And there is one. It looks like this. One of the big 5 uniform acceleration formulas. And v2 is 0, so I'll just cross that out. Replace it with a 0. And I'm going to be solving for v1. solving for V1. Can you see how that works? We're going to first subtract 2a d, both sides, and then we're going to square root both sides. So one of those plus or minuses, one of them is going to be inadmissible. We're going to want a positive answer because initially he launches himself upwards, so the negative is going to be inadmissible. Okay, I'll fill in the values. And again, I'm happy that I see a -2 times a -9.8. So negative times a negative is a positive. So I'll end up with the square root of a positive number. That's a good sign. We get the calculator out. Round my answer to 2 sig figs, so that's going to end up being 4.7 meters per second, and this is a vector that I'm dealing with, so I need a direction here. That's going to be up, which is consistent with the directions of everything I put in my list. All right, that is Zion's vertical.